Okay, so, it's a little blurry there. There it goes. All right, so, do y'all remember at the beginning of this unit on quadratics, we started out graphing, right? Okay, and if you'll recall, I said that the thing that we're the most interested in is right here and right here, where it hits the x-axis. What were those points called? That's one name. What's the other two? Roots is one name. What's the other two names that are sometimes used? All right. So you need to remember this. So sometimes we call them roots. Sometimes we call them zeros. And what's the last one? What's the last one? Solutions. Solutions. It's called one of the three. So if I ever use those three terms, I'm using them meaning the same thing, okay? So, and if you also recall, I think, what was it, last week or week before, we started doing this whole factoring stuff. I told you that we're going to get bogged down in like procedures and how to do basic stuff like that. But I don't want you to lose sight of what the point is. The point is we're going to use that factoring to actually find the roots of a quadratic. So this is one we actually just done a second ago. I want to show you how that actually works with a simple one. Then we'll jump into some more, a little more involved. So, y'all remember the answer to this one? Like when we factored it, do you remember the answer? Right. So the one new step that we're using here, or we're going to take is, we're going to take both of these and we're going to set them equal to 0. Here's why. Every coordinate, or I'm sorry, every point on the x-axis, they all have a y-coordinate of 0, right? So like this point right here, that'd be 10, 0. That's 0, 0. You see how like every time it's the y value 0? That's why we do that. So what we'll be doing today is taking each factor, setting them equal to 0, and solving for x. So with this one, what would be your answer?
5.
Ooh, that took a while. Okay. All right. So what's this one? Yeah. All right. So look at your x-axis. Where are they hitting? 5 and negative 5. That's what the factoring stuff does for us, is it helps us to be able to find these points. Because sometimes what will happen is the graph might fall kind of like in between, like that right there. We can guess it, can't we, about where it should be? But as far as graphing, it'd be very difficult to find that spot. Factoring can help us a lot of times. Not always. There are times where it fails, but that's kind of what it helps us with in general. So with your paper that you have, I'm going to swap my screen. Here's kind of how I want to do the flow of the lesson here. I want to work these odd ones out with you so you can get a good idea, and then I'm going to let you try the evens yourself, because they kind of mirror each other very well. So if you get lost, you can look at the one next to it and go, oh, okay, it's probably something like this. So let's start with number 1 here. Well, get to stay right there. So do I have a GCF? Now, as far as starting out with these, just ignore the equal to 0 just for the moment. Now, that you do need to make sure that these are all set equal to 0. That's important. But for the time being, it's good. No GCF?
1. No, wait.
Now, as far as the one, like a 1 and a 9, yeah, 1, but
9?
there's no GCF at all.
Yeah.
These two right here. There's no GCF at all.
9. The only number there would be 1 or 9. Not 1, I mean. There's not a GCF.
You're missing the forest for the trees, guys. They both have an X, don't they? Can I pull an X out? Yeah. It's not always just the number, right? It's the variable too. You got to consider them as well. So can I break this down any further, or is this part done? That's done, right? It's a linear binomial. I mean, that's pretty much all she wrote for that one.
But how is that going to equal to 0?
Right. So now we're going to take both of these. See, this right here is a factor, and this right here is a factor. So I'm going to take the first one, say x equals 0. I'm going to come over here and say x plus 9 equals 0. That'll be easy to solve for x because it already is. It's already x equals 0. What's this one? Negative 9, yeah. That's your two roots.
So that's it?
That's it. That's it. So we use the factoring stuff that we've learned previously to find the roots. Now, the factoring might get more involved the further we go, but that's the overall structure. We factor it, and then we set them equal to 0 to find the roots. So let's look at number 3. GCF at all in there? No? All right, so I do have a minus sign, and it's 2 terms, so that should be like a big red flag. Maybe we can do a special case. Can I do it here? Okay, so what y'all probably already figured it out. What is it? Yeah. All right, so we're setting those equal to 0.
I keep looking at the 0. That's what happened.
Yeah, the 0 at the very beginning of it, just kind of forget it's there. Don't literally forget it's there, but as far as the factoring, you're just dealing with this part right here, and then you'll come back to deal with that later.
Yeah, I thought I got that. I was confused.
Okay, let's take a look at number 5. So, is there a GCF on number 5? No. And just you notice how I keep asking that every time. You know, make sure you're doing the same thing when you do yours. Okay. So, can I? What should I use? The bottoms up or the X method? Just the X. How do you know that?
Because I learned this from the past.
Yeah, that's true. Yeah, you did. The A value, right?
Yes.
The A value is equal to 1. So all the factors are 21. That should be hard. You think I got them all? No. Unsure. All right, so they got to multiply and give me 21, but add to give me a negative 10. So I think we figured out pretty quick which ones they are, right? 3 and 7. Oh, okay, that's what I was going to ask about. Yeah. See, negative 3 and negative 7, right? So x minus 3, x minus 7 equals 0. Go ahead.
You know how it said equal, it's negative 3 and negative 7?
Yeah?
Why is x equal 3 and x equals 7? It did not come back.
Because I solve for x. I add 3 to both sides. I add 3, so it's x equals 3. And then I add 7, x equals 7.
Okay. You good, dude?
Now, with some of these, you can actually, if you're pretty slick, you can look at them and just kind of tell. So the whole idea is, what number could you plug in for x right here to make this go down to 0? 3, right? And this right here, what number? You have to set the same question. 7. So I mean, you could, if you're really quick and like really slick, you could do that pretty fast. Let's look at one more. Then we'll let you try it on your own. So number 7 here. Do I have a GCF? 3, 13, and 30. None? No, because 13 itself is prime, right? Okay, so what method do I need to use for factoring here? The bottoms up, because that value is bigger than 1, right? Let's see if you can finish it. Because some point I have to hand the reins over to you. So factors, multiplies give you negative 90, but add and give you negative 13.
Oh, yeah.
And it may be beneficial, you make your T-chart. That might be the best way to do that, because some of these can be a little cumbersome.
What do you mean? One of these two is wrong.
Am I missing any? I just went off the cuff there.
Round it. Yeah, I figured it.
Hmm?
I figured that
What? So which ones are going to work? 5 and 18? So 5 and negative 18. Right, because they got to give you the negative 13. Okay. All right. Okay, now do I stop here, or is there another step?
There's another step.
Okay, what is that step?
So we have to add in. You have to divide.
Divide.
From the divide by 3.
Yeah, there you go. Now I'll show you something kind of cool here. Check this out. So 18 thirds is 6, right? So it's x minus 6. Now, when in the context of solving for roots here, you actually do not have to go and like rewrite this, put the 3 in front. If we were just looking for factors, period, you'd want to do that because when you FOIL it, you want to make sure you get the same thing. But with this, actually, you could solve it as it stands. That's actually okay.
I like how this problem is mutated to something. First it started as a little creature, now it's just a monster.
Okay, so probably the most difficult of them would be like you having to use the bottoms up method to factor. That's probably the most difficult ones. And difficult, I'm doing like, yeah. The more you do them, the better you'll get at them. So the big thing is don't quit because it looks hard. Put your nose to the grindstone and try it. That's how you get better at them. Okay, so your task is this.